position of the Earth as it revolves around the Sun is the best place to begin in order to understand weather and climate. Observe that the Earth is tilted on its axis relative to the plane of its orbit. The axis is tilted toward or away from the Sun to some degree all through the year, except on the first day of spring and the first day of fall. It's this tilt which affects the length of our days and causes the changes of our seasons. Let's take a look at just how the tilt affects the length of our days. First, we'll get a close-up look at the Earth on the first day of spring. This day is called the vernal equinox. From this position, we can see that on this day, the poles tilt neither toward nor away from the Sun, and the line between night and day passes directly through the poles. The result is that day and night are equal in length everywhere on the Earth. To illustrate this, let's follow the city of New York through its daylight hours. We'll start a 24-hour clock as New York crosses from darkness to daylight, and follow the city around to the evening side. You can see that the clock has stopped at exactly 12 hours when New York crossed from daylight to darkness. If we move up above the North Pole and look directly down, we can see that as the Earth rotates, any city will have exactly 12 hours of daylight and 12 hours of night. The other time of the year when this happens is on the first day of fall, which is called the autumnal equinox. Now let's follow the Earth in its orbit around the Sun and meet it again on the first day of summer. This day is called the summer solstice. From this point, we can see that the North Pole is tilted toward the Sun and the South Pole is tilted away. From higher up, we can see that the region around the North Pole has constant daylight. This region lies within the Arctic Circle. From down below, we can see that the region near the South Pole is always in darkness. This region lies within the Antarctic Circle. Between these two circles, days in the Northern Hemisphere are longer than 12 hours, and those in the Southern Hemisphere are shorter than 12 hours. Let's look at New York in the Northern Hemisphere and Buenos Aires in the Southern. We'll start a 24-hour clock for each when they pass through into daylight, and we'll stop the clock when they go into darkness. As you can see, New York has about 15 hours of daylight, while Buenos Aires has only 9.5. This situation is reversed on the first day of winter, when New York has about 9 hours of daylight and Buenos Aires has 14.5. Now let's follow the Earth in its orbit over a year and watch on the clock how the length of the days change for New York in the Northern Hemisphere. During the spring, the days get longer, going from 12 hours to about 15 hours on the first day of summer. And then, during the summer, they start getting shorter again, going from 15 hours to 12 hours again on the first day of fall. During the fall, they continue to get shorter, going from 12 hours to about 9 hours on the first day of winter. And finally, during the winter, the days start getting longer again, going from 9 hours to 12 hours on the first day of spring.